everyone, welcome back to my YouTube channel AI Stories by Anjali. In today's video, we are going to discuss about the topic how you can create a simple application using RAG model with the help of LLAMA Index. So this is our primary topic today, and I will be discussing as much as I can in the 15 minutes of length in today's video, and I will be continuing the remaining part and part 2 in the next week. So we'll be discussing about this application in part 1 and part 2. So before going to that, I'd like to thank to all my subscribers who have subscribed to my YouTube channel, and also requesting to the new watchers to please like, share and subscribe to my YouTube channel AI Stories by Anjali. So let us dive deep into the video. So firstly, what is RAG? RAG stands for Retrieval Augmented Generation, and LLAMA Index. LLAMA Index is nothing but you can query a simple document efficiently using LLAMA Index. Okay. So these two concepts already we have discussed in the last week in the theoretical conceptual video. So now I will be showing how you can use those concepts in the real world applications. So first step, as usual, whenever you're doing any project or anything, the first step is you have to make sure all the required packages have been installed in your system. So for that, you have to run these commands. So as usual, I will usually mention whenever you're installing anything in Python or else in Anaconda, Jupyter Notebook, you have to make sure you're installing with pip install command. And if you're using Anaconda prompt for installing, then you can use conda install -c conda -forge the package name. So these are the things that you have to be familiar whenever you're dealing and installing packages. So first package is OpenAI, and then LLAMA Index and AWS CLI, that is command line interface, and the these three, that is FS, S3FS and S3FS and FS-SPAC. I will be discussing about these packages when you get at that point. Okay. So first we have to install all these in your system. Once you're installed, you have to make sure those should be come into the picture once you get refreshed and restart your notebook. So for that, you have to run this command. Okay. So make sure you refresh, and so that the install packages, that is the latest install packages, will come into picture. Okay. Once you're done with it, the application, that is the actual application, will be starting from now. Okay. So as I mentioned, what is RAG? So when you're doing RAG model, you are providing as an additional secondary sources for your existing application, so that it can use those sources and it can efficiently give your response for your application. So for that, you have to create the authorized secondary data sources. So now I am creating that. For that, you have to import the packages. Those are pandas, S3FS, FS, S3FS and FS-SPAC. Okay. Once you get import, you have to read the files. So my files I have stored in the S3 bucket. So these are all my files. So I have 5 additional secondary sources to the application that I want to send. Okay. So I'm reading those files from the S3 bucket, which I have there. Which I have kept into my S3 bucket. Okay, so you can read with this syntax, that is pd.read table. So pd is pandas and read underscore table is a method in pandas, or a function you can call, and you can just keep the URL of the S3 bucket. This is the entire URL of the S3 bucket. And then you can give the structure, cosmic structure file. That is one of the file name that I have stored in my S3 bucket. And this is the second file, and third, fourth, and fifth. So total I have 5 different files in my S3 bucket, which I am giving as a secondary data source for my existing application. Okay. And then once you're done with that, I'm creating a folder that is space documents, and I'm keeping all those particular 5 files into that document. Space documents folder. Okay, so I'm creating that with the help of this command, that is mkdir, that is make directory space documents. So you're creating a space documents directory, or that is a main folder for storing all these 5 files. Okay, and once you're done with that, now for each of the 5 files, we have to create 5 different data frames. Okay, so for that I am using this syntax, the df underscore list equal to all the 5 data frame names that you want to create, and then file list, you are passing all the 5 files as a list. Okay, once you're done with that, you're giving the path, that is the space document directory that you have created, and then you're reading everything with the help of open method, and make sure you have to read and write into that particular thing. Okay, so for that you're using W. Okay, so W stands for write, and this open method contains read, write, append, etc. These 3 are the most commonly used functions. Okay, so you're writing each and everything in these files into these data frames, and you're calling that. Okay, here that is df.to underscore string header equal false and index equal false. So this part will write the files into the space documents folder for each of the 5 files into the 5 different data frames. And then you have to see how far you can retrieve manually the best documents to augment the base model for getting the response for your query. Okay, so for that you're just doing this prompt. So I know what is, I have already explained you what is prompt, right? Prompt is nothing but you are giving the rules and regulations and what exactly that you want your LLM to do. So that you're giving the form of prompt. Okay, so here the prompt that I want to get the answer is, what methods and tools do scientists employ in their pursuit of detecting signals from intelligent life beyond Earth? So this is your question. Okay, so first you have to review all the 5 documents that you have sent and make sure to select one most relevant document for your query, that is for your prompt, the question that you have passed. Okay, so this is the thing for reviewing the documents. Okay, first you have to import the OS and then you're reading like you're just reading all the documents. For that I'm just creating a simple function so that it can be reusable at any point of your code if you're necessary. Then read underscore text underscore file is a function name, and you're giving the file path as well as the document number, and then with the help of open method you're reading that. So I kept R, and this is a variable, and then you're just formatting the document number, and then you're splitting with the help of period, because in each and everything for every sentence the ending will be the full stop, right? So you're splitting that by full stop, so that, and then you're just reading that, and you're giving the directory, and then you're looping for each of your directory and telling whether it is ending with .txt. You just keep that file into the directory and just call that entire file. Okay, so you're printing each and everything. So this is your document 1, this is your document 2, 3, 4, 5. So you are reviewing every document that you have sent. Now you have to select the best one. Okay, so that means for your question, that is, this is your question, what can be the best relevant document for getting the answer? So from the 5 documents, I have selected the 5th document as the best relevant document for answering my query, and then I'm creating a new document underscore text variable, and then I'm just copy pasting this relevant document into this variable. Okay, so once you're done with that, as usual, the remaining step is you have to give the prompt, and make sure in the prompt you give all the relevant rules also. Okay, so the prompt question, and then you're telling get the answer from the following text, and you're passing the document text because that is the relevant document that you're sending. And then this is the most commonly used step that every time that we will use whenever you're building the LLM applications using OpenAI, and I have explained so many times in my video. So you're just importing a JSON package, and then you're importing the OpenAI package, and then giving your API key, and once you're done with that, you have to initialize the client, and then you have to call the completions.create method for giving the model parameters, that is the model name and the prompt, the temperature, and max tokens. And here I'm using GPT 3.5 Turbo Instruct model, and I'm giving the temperature as 0.1 and max tokens as 64. Of course, you can play with your parameters, and you can see how it is doing. And I have clearly explained what exactly temperature and max tokens means. So go and if you have any doubt, you can go and check it out in my previous videos. And once you're done with that, you're just printing the response, the text part of your response. And in this way, you're getting the answer. Okay, so let us see the answer, what it is telling. So it is telling some of the methods and tools used by scientists in their pursuit of detecting signals from intelligent life beyond Earth include radio telescopes, and these are large, highly sensitive instruments that are used to detect and analyze radio waves from space. Scientists have radio telescopes to see and can sky for any unusual or artificial signals that. So this is your answer. Of course, this is okay. This is a pretty good answer, but you can improvise that from your existing LLM application by using the LLAMA index. So we'll create a LLAMA index and a simple text reader, and we will load and vectorize the documents. So vectorization is important, as I told. So vectorization is nothing but you're converting your text into a series of vector values, and then you can create or construct a tree index from all the documents in the space documents, and you can efficiently query. So that part we'll be discussing as a part 2. So till now in this video, we have seen how you can create a secondary data source, and how you can create a data frame from the files that you have read as a secondary data source, and you can see how you can develop a simple RAG model for the secondary data sources that you created. That means you have given a query and you have selected a relevant document from the secondary source, and you can pass those particular things to the model and see how it is working. So this is what we saw, and of course the answer is good. So we'll be discussing how you can improvise that in the next part 2 video using the LLAMA index. So I hope you understand this video. So stay tuned for the part 2 in the next week. So thank you so much for watching the video. Thank you.